12.1a is tangent lines. And we are, like I said, dealing a lot with circles. So you'll get good at drawing free-handed circles if you do this with me. First thing we're going to do is just talk about what a tangent line is. So I'm going to give you an example of a tangent line. In order for a line to be tangent to a circle, it has to go through exactly one point on the circle. So that's not the best. Let's try again. Better. Okay, so it'll look something like this. We would say the point where it hits the circle, right here, is called your point of tangency. Okay, and if it's going to be tangent, it can only go through one point. You with me? Yeah. So there's this theorem with, doesn't look very circular up here. There's a theorem with tangent lines that says if a line is tangent to a circle at the radius of the circle, it will always form a 90-degree angle. So if I were to draw a radius here, that's not a radius. Okay, so if this is a radius, that angle that's formed by the tangent line and the radius every single time will be 90 degrees. Okay, and that's what you're going to use a lot today. They're not going to tell you it's 90 degrees. They're going to tell you the line is tangent. So they're not going to put this in the problem. You just have to know that because it's tangent, it's a 90-degree angle. Okay, so we would say, just for information purposes, if this is A, B, P, and O, we would say OP is perpendicular to AB if AB is tangent. We'll say tangent to circle O. Okay, so if it's tangent to circle O, then it's a right angle. It will be perpendicular. Questions on that? Okay, so I have 3 examples that go along with that. 2 that deal with, well, it's kind of 4 examples, I guess. 2 that deal with angle measures, 2 that deal with side lengths in this scenario. But all of it deals with the fact that you have perpendicular lines in the problem. All right, example 1. If we have a circle here, and then we're going to have 2 tangent lines. So a tangent line here, another tangent line here. So here's a point of tangency, here's a point of tangency. And then if this is the center of our circle, that means we have, that's not what I want. You have a radius here and a radius here. Okay, so I'm going to say this is A, B, C, D, and we're going to say that AB and BC are tangent to circle D. Okay, so that's the information you're given, and then they tell you that angle D is 152 degrees, and we want to know angle B. Anyone see a way that you can figure that out? Yeah, Akeem. And do what? Split what in half? A quadrilateral? A kite? Okay. Okay, you could do that. That's not the most efficient way to do it, but you could get there that way. Anyone see a different way that maybe is a step less? Why? Okay, you're right. Yeah, Alyssa. There you go. So you can make it a triangle, but you don't need to make it a triangle because right now it's a quadrilateral. And what do we know about A and C? They're perpendicular, right? If they're perpendicular, that's 90 and 90. So you're looking at a quadrilateral. Quadrilateral always adds up to what? 360. So you can say 90 plus 152 plus 90 plus x should equal 360. So when you take that away, what is that? On my calculator. So this is 332 plus x would have to equal 360. So if you take that 332 away, then you get 28 for your x. Okay, so if it's a quadrilateral, quadrilateral is always going to add up to 360. Questions on that? You just have to make sure they're not going to tell you this, they're not going to tell you that. You need to know that a radius and a tangent are a 90-degree angle. Yeah. Yeah. In this one, when there's two tangent lines, you can do that because 360 minus the 180, those two would have to be 180 then. Yeah. Any questions on that? Okay, this one's a little bit different. What do you do with this? If I give you, whoops. So you have a tangent up here. This is going to be a diameter. So this would be the center of our circle. Come on. Okay. Good. Okay. So if this is 38 and we want to know this angle, what do? Right, so now it's a triangle, right? So it's got to add up to 180. We know this is perpendicular. Actually, we don't know, but I'm telling you right now, AB is tangent. Okay, so if AB is tangent, then this has to be 90 degrees. So you have 90 plus 38 plus x, that would have to add up to 180. So you're just going to take that 128 away, which means x is going to be 52 degrees. Okay, so when dealing with angle measures, which is these last two problems, look at what your figure is. Is it a quadrilateral? Then they got to add up to 360. Is it a triangle? Then they got to add up to 180. Okay, that's angle measure. Now we're going to talk more side length, but with the same general setup. So this is example 2. You're going to start with a circle. And I'm going to apologize in advance that this is not drawn to scale. But I will do my best. All right, so if this is our setup, this right here, that itty bitty little piece, is 6.5 miles. Okay, that's just this piece of it. the radius here is 4,000 miles. Okay, and I want to know y, not W-H-Y, the letter y, the variable. I want to know what y is. So if I tell you that this is tangent to the circle, how can you find y? What do you know? You know it's tangent. What does tangent make it? 90 degrees. So you know you have a right angle here. So we're dealing with a right triangle. Do you know this piece? What's this? That's 4,000. It's a radius, right? A radius is a radius no matter where you put it. So this is 4,000. Okay. So how do I solve for y? Pythagorean theorem, right? You're just going to do Pythagorean theorem with this. So we're going to do 4,000 squared plus y squared. And then your third side would be 4,006.5 squared. So when you simplify that, you get y squared equals 4,006.5 squared minus 4,000 squared. Oh my word, you guys. So if we square root that, you get that, if we round to the nearest mile, we'll say, because we're talking miles here, you get about 228 miles. Okay? Questions on that? Okay. If you checked out for the first examples, you need to check in right now, because I promise you're going to see this again, and people always do this one wrong. So pay attention so that you've got this. Here's what we're doing. Example 3, you have a circle. And some tangent lines. So we're going to do a line here. A line here. Not some tangent lines, a tangent line. Okay, so here's what I'm going to tell you. This is not my best circle. Sorry, guys. X and X. Pretend those both look like the same radius, because they would be. So this is the information you have. That line 24, okay, so I'm going to tell you this one is tangent to the circle. How do you solve for X? It's Pythagorean theorem, okay? So we know that this is a right angle, which means if we set this up with Pythagorean theorem, it's x squared plus 24 squared equals, and here's where the mistakes usually happen, x plus 18 squared. You are squaring a binomial. Does anyone remember how to square a binomial? Who said it? You FOIL, right? What people want to do is just distribute that squared and call it x squared plus 18 squared. That is wrong. Don't do that, okay? Instead, you're going to FOIL. So remember FOIL, first, outer, inner, last. So if you need to, you can set it up like this. I'll show you the shortcut. I'll remind you of the shortcut in just a minute, but I want to just make sure you get FOIL in case you don't want to do the shortcut. So if we FOIL this, it's x squared, right? That's your first. Your outside would be x plus 8, or x times 18. Your inside is 18 times x also. And then your last is 18 times 18, which is 324. That's 24 squared. 576. Okay, so right now it looks like this. If we simplify again, it's x squared plus 576 equals x squared plus 36x plus 324. Here's where I'm going to take a quick break from solving it and show you the shortcut. This from this, do you see what happens? You square your first number, you square your last number, and then that middle term is 2 times the first times the last. Remember that shortcut? We don't spend a ton of time on it in algebra, but the shortcut is there. So if you want to do the shortcut when you FOIL, that's fine. Just make sure you're doing it the right way. So it's 2 times, so if we do it like this, here, I'll just write the shortcut out for you. If you have a plus b squared, your shortcut is it's a squared plus 2 times a times b plus b squared, right? Okay, so if we finish solving this, you're going to take away x squared, which is going to give you 0 here and 0 here. So really you have 576 equals 36x plus 324, which is beautiful because now you don't have to factor or do the quadratic formula. So you're going to take away 324. So you get 252 equals 36x, and then you divide by 36, and you get x equals 7. Okay, now if you're really good, you don't have to do any of that work, because when you look at this problem, you see a 24 and you think, what triple has a 24? Oh, I know, 7, 24, 25. So you check, if a 7 goes here, do I get 7, 24, 25? And I do. So if you have spent any time memorizing some of the most common triples, 3, 4, 5, 6, 8, 10, 5, 12, 13, 8, 15, 17, 7, 24, 25, they show up in this, and then you really don't have to do the work for it. You can just take that triple and plug it in. But again, you need to weigh which one is more important to you, spending the time to memorize the triples or spending the time to work out the problem. You could do either way. Yes, sir.
Wait, so if you just know what that is, then why don't you just like figure it out?
That's what we did. This is Pythagorean Theorem.
That's enough.
This
That's so much.
is Pythagorean Theorem.
Okay, but could you just do like go back up? Could you just do 24 x or 24 squared plus x squared equals 18?
You can't do 18 because it's x plus 18. That's why the FOIL happens, right? That's why the long part happens. So yeah, you have, if you're going to do Pythagorean Theorem, you have to FOIL or use the shortcut to FOIL. Okay? Any other questions? Okay, so Pythagorean Theorem for all the side lengths, and then for the angles, they either add up to 360 if it's a quadrilateral or 180 if it's a triangle. Okay?